Okay, so in our previous lesson we talked about the different parts of a circle, and the outside measurement, remember, is called the circumference, so that's approximately the perimeter of a circle. But because it doesn't have any edges, we can either use the radius or the diameter of the circle to get that approximate circumference. And here in the next couple lessons, we're actually going to go ahead and see what those formulas are when we see those on our math chart. But we're just trying to get you kind of used to the idea of how we can figure out that circumference. So that was that RDC times 2 times 3. But today's lesson, we're going to focus just on the radius and the diameter. So remember, by definition, the radius is from the center to the edge of a circle. So right here is the radius, but even right here and right here, we could rotate this around. It doesn't necessarily have to be a straight up and down line. So for example, in this circle over here, circle B, from the center to the edge is also the radius. Then the diameter is a special kind of chord. A chord is a line segment on a circle, but the diameter specifically has to go through the center. So again, we could actually rotate it just like this. So from this finger to the next, as long as I go through the center of the circle, that is the diameter. And again, you can actually see that we can rotate this radius down right here. And from the center to the edge, this would be the radius. And from the center to the edge right here, this would be the other radius. So that we could see that there's actually 2 radius for every 1 diameter. So something to think about for that, okay? Just before we move on, just want to label this right here. If I have a line segment like that, from this dot to this dot, from one end to the other, this is called a chord. So a chord is a line segment from one end to the other on the circle, but it's not going through the center. So we could do from here to there, any line segment from one point to the other on the outside of that circle, just not going through the center, okay? So really important to know that vocabulary. So what we're going to do is we're going to fill out this table. So remember, from radius to the diameter, we're going to do multiply by 2. But if we know the diameter, well, if the radius is half of the diameter is half of the radius, is half of that diameter, because there's 2 radius for them, we can do divide by 2. So it just depends on what we're looking at, okay? So A, B, and C, we're going to use these pictures over here. So we're going to measure these out. And we're going to round to the nearest centimeter. So if you have a ruler in the copy of this paper, you're going to measure it out. If you don't, just watch what I'm doing and we'll get you that practice. Okay, so make sure that we're on the edge with the centimeters. And see how this starts a little bit above it? We don't want to put our ruler right on the end where you don't see that line. So right here where that line is, we're going to put that there. So for example, that line doesn't start right there, so we're not going to start our picture right there. We're going to start right where the line is. So when you measure that out, that looks like it's about 6.5. But let's decide what this is, 6.5 centimeters. From the center to the edge is the radius, but this isn't just going from the center to the edge, it's going from the outside through the center to the other, so this is the diameter. And we are using the diameter in that yellow color, but that's going to be hard to see, so I'm just going to put the letter D for diameter. So this actually represents the diameter itself. And if we're going to round this to the nearest whole number, we're going to say that it's 7 centimeters. Okay? We're going to come back to do the math in just a minute. We're just going to measure these out. Then for letter B, I'm going to rotate my ruler over here. See again where I'm starting with the line? I'm not moving it up here on the dot because that's not where it starts. It starts right on that line. You're going to get about 1.8. See, that's 1.5, so maybe about 1.7, 1.8. So from there to there, let's say that's about 1.8 centimeters. And if we're going to round that to the nearest whole number, well, that's going to be 2. But from the center to the edge, if we look at my picture, that's going to represent the radius. So really what we're trying to do first is just talk about what these represent. So round to the nearest whole is going to be 2 centimeters. Okay? So let's measure out this last circle, and then we're going to put these numbers together and see what's going to happen. So from the center to the edge is the radius from the outside through the center to the other edge is the diameter. So in order for it to be the diameter, it has to go through that center. So when we see that, you're going to see 9, I know it's a little bit dark, 9 point, a little bit over 0.5. So if we round that to the nearest whole number, it's going to be 10 centimeters. So again, my estimation was about, or excuse me, not my estimation, looking at the rule is about 9.5 centimeters, but my estimation, if I round that to the nearest whole, well, that's not my radius, but it's my diameter. So if you label that first, I'm going to say 10 centimeters. Okay? So now what we're going to do is use these numbers according to this table. Okay? So for circle A, the diameter was 7 centimeters. For circle B, that represented the radius of 2 centimeters. And for circle C, we said the diameter was 10 centimeters. So here's the good news. Once you know one, you're going to know the other. So follow your arrows. If I know the radius, I'm going to double it to get to my diameter. If I know my diameter, this is like my starting point, and the arrow is pointing to where I'm ending, I'm going to divide by 2 because half of your radius, half of your diameter is your radius. So if I know 7, I'm going to divide by 2. Okay? So if I say 7 divided by 2, 2 goes into 7 3 times. 3 times 2 is 6. Subtract. And then I'm going to bring down a 0 after I add that decimal because 7 0/10 is the same thing as 7. And 2 goes into 10 5 times. So my radius is 3 5/10 centimeters. Okay? So now I know my radius. I want to get to my diameter. So radius, well, 2 of my radius, if this was 2 and I have another 2, you could see that would be a total of 4. Okay, so visualize it with that picture too if it helps you. So 2 centimeters times 2, because 2 radius make up your diameter, it would be 4 centimeters. Okay, now my diameter is 10, so what would this radius have been? What plus another amount, or what times 2 got you to 10? Well, 10 divided by 2, so my radius would be 5 centimeters. Okay, so that's what we're looking at. So we're just really making sure you know the connection between the radius and the diameter, because sometimes will be these questions where they're going to ask, if this is the diameter, what's the radius? If this is the diameter, what's the circumference? So we're just focusing on the radius and diameter today. So 9 centimeters to get to diameter, I do times 2. So 9 times 2 is 18 centimeters. If I know the diameter is 12, I'm going back to radius, so 12 divided by 2. It's 6, and my units on that one was miles. 4.7 meters to get to diameter, do times 2. So if I do 4.7 times 2, so we're reviewing dividing decimals and multiplying by decimals. Remember, you have to line up the digits. Pretend like this was 47 times 2. 2 times 7 is 14. 4 times 2 is 8, plus 1 is 94. But it's not really 94. There's one number after the decimal here, 0 numbers after the decimal there. 1 plus 0 is 1. So we need a total of 1 number after the decimal in the product. So we move that back. Once to the left, so 9 4/10 meters. Okay. So again, just focusing on the relationship between the radius and diameter, and then the upcoming lessons we're going to put it more together with the radius, diameter, circumference, and then also be using the formulas. And we're practicing this so that when we are using those formulas, you need to identify which part you're looking at so you use the correct formula. So again, kind of breaking it down so when we get to those formulas, it's going to make all perfect sense for you.